All right, Vivian, it's 4 o'clock, so just let everybody know what best to go. Vivian will have about 30 minutes to present, and after that, we'll have 15 minutes of question time. And then after that, we'll have everybody excuse us from the room while we deliberate, and then that will wrap it. So, Vivian, we'll go ahead and turn it over to you.
Yeah, hi everyone. My name is Yixuan, and the thesis title today I'm presenting is AI Emotional Memory System, Simulating Semantic Knowledge, Episodic Memory, and Short-term Memory. And the contents that I'm going to cover are introduction, architecture, artifact itself, and the future usages for this memory system. And let's begin with the old AI examples, where you'll remember these large behavior trees, quite robotic. And also, the AI decisions are not based on the memories, but instead they're based on some fixed memories with parameters and the instant current moment. And so let's watch the example of the AIs in the Hitman 2 in this video. And where you can see there is a broken wire with Dr. Papers spilled on the ground, and the AI seems to be reacting with fear and then just calmly walk toward this spot without seem to knowing what was happening here, without remember what was happening just now to their allies. So what should a real intelligent AI behave in this circumstance? Just like they should learn from the past, like there are bodies piled up, and they should have some more human-like reactions, like fear. And these emotions should be varied considering their characteristics and their past experiences. So I want an AI that can tell you what happened in this alley, and even altered this AI's previous liking for Dr. Paper because of its traumatic event. So the memory system itself is based on APF library, which is the artificial psychosocial framework built on Jake Clinkert. And the flow for this framework is starting from the perception of the game board and then transferred into the ANPC, which is the affectionate non-player character, and it will based on the APF library, which will consist of the characteristics describing the NPC, as well as the social relationships definition, and generate a corresponding, more correct emotion toward the perception of the game board. And what I have done is to add in this memory system that can help evolve the characteristic of NPC throughout game playing process, and also help with emotion generation, and to help NPC to make a more correct response with the past experiences for the game perceptions. And here is the large graph for the OCC emotion model that I use for the APF library. But actually, I don't expect you guys to read every single word of it. I'm going to go through them one by one. So for this emotional model is hierarchy, which means the emotions later will be based on the emotions generated on the highest hierarchy. So for witnesses, starting from witness is the subjective spectrum of positive to negative evaluation of an experience a person may have had. So like eating an apple would have a positive witness of 0.3, or a bad apple. And eating your favorite steak at your favorite French restaurant will have a positive witness of 0.9. And then let's talk about the memory system. The memory system actually focuses on this single branch that is connected to the consequence of the events. And for generating event-related emotions based on memory system, it is involved more things like based on the 0.3 witness of eating the bad apple, it will generate several moods based on them. So because the actual result is quite negative, so pleased will be very low, and displeased will be high. And then emotions will be generated from those moods. Emotions are the chemical release in response to your interpretation of specific situation. And it takes our brain a quarter of a second to identify the trigger, and another to produce the chemical. So before eating the apple, actually you were hoping the apple is good. So your hope will be very high and your fear will be very low. But after eating, you find out this apple is bad, so your joy will be low instead, and distress will be high. And then, based on those generated emotions and some other ANPCs and events that is included in this generation, the feelings will be generated. Feelings can most cases will last longer than emotions. And so use the example of the disappointment. Like disappointment by definition is the consequence. This confirms the prospective desirable consequence. And in the human words, it means that you are expecting the apple is good, but what you have eaten is a bad apple. So your disappointment will be very high in this circumstance. And let me introduce the scenario that I'm going to constantly use throughout the explanation for artifact. Say that after this traumatic destined event of eating the poisonous apple and almost got killed, Snow White, in a far future, got hungry again, and this time she just got an apple that could be eaten. And for the perception itself, Snow White knows that she's hungry and she's got an apple that could be eaten, and directly appraised, which like evaluated from the APF library, she would feel very happy toward the event of eating the apple because she likes apples and she likes eating. But from her memory system, she could tell that once upon a time, she had this very traumatic bad event happening in the past about eating the apple. So when trying to make a genuine response toward this perception, she's trying to combining these two emotions and these two circumstances together to make the real response. And let's just assume that the Snow White this time is a very nearsighted person or forgetting, which means that she didn't think the memory is that important. So as a result, she would kind of happily decide to eat the apple, and not that happy because she already interfered by the negative prospect of the memory system. So to discuss about the appraisal process in detail, it starts from this perception and of being hungry and with an apple. It will feed into the APF library with many predefinitions, and this library will just give out a direct raw emotion based on all those settings, which is Snow White would be very happy after eating the apple. But from the memory system will retrieve every related memory traces that she remembered. That means every history after Snow White in the past ate an apple, what would happen? And from those traces, a prospect will be generated. That means the prospect for what would happen next if Snow White eat the apple now. And because this traumatic event of being fainted and almost got killed was so impressive, so Snow White will have a generally negative prospect toward the future of eating the apple. And the actual emotion will be generated thus by combining the negative prospect and the very happy raw emotion, which on the basis of our assumption that Snow White is very forgiving, then Snow White would have a kind of happy emotion toward the whole event. And in the meantime, actually, these past memories of the past experiences can also help the Snow White to select from all those possible actions that she had done once and select between whether to eat or not based on her current actual emotion and her characteristics. And all those outputs will be concluded and be output into the appraisal, and to help the NPC, which is Snow White, as a conclusion, will choose to eat the apple with a kind of happy emotion. And of course, it will be remembered back into memory system as her real choice. And before talking about the memory system architecture, I'd like to introduce the human memory model, because the memory system is actually designed based on the actual human memory models. This Atkinson-Schifrin memory model is one of the most famous memory model that we use. So it starts from a sensory memory, which is Snow White could smell the sweetness of apple that is placed on the ground. And after some attention selection, this piece of memory could be remembered by short-term memory. Short-term memory usually lasts for seconds or minutes, very short and with limited space. So only the memories with proper rehearsal, which means that after this memory has been rehearsed or being repeated for so many times, or this piece of memory is emotionally salient enough, then it will be transferred and really deeply branded in your mind, which is the long-term memory. For long-term memory, it usually lasts for hours or even your whole life. So that's quite different for these two. And there are generally two kinds of memory for long-term memory. One is explicit, the other is implicit. And for my memory system, it really implements these two branches under explicit memory. The first one is episodic memory, which is for events and experience. So this piece of memory, Snow White 7 years ago in the forest ate the poisonous apple and almost got killed. This is a whole event memory, so this is episodic. But for semantic memory, this is about the concepts and facts, more like general knowledge toward the world. Like Snow White would know without any doubt that an apple could cure her hunger. And then directly, let's talk about the actual memory definition in my memory system. For one memory that I'm going to use in the following times, it will include two parts. The first one is the state of the NPC itself, which is like Snow White is not happy. She's currently in the forest and she's currently very hungry. And also another major part is the state of the game, which includes the state of the other NPCs. Like the witch right now is anxious and is waiting for Snow White to accept this poisonous apple. And also state of the game include state of other objects, like the apple right now is poisonous, or any other kinds of information depend on actual games, like it was the dawn of the day inside of the game, and etc. And for the action that I'm going to refer to, this will include an initiator, which is Snow White, and a patient, which is the apple. And the action itself will be eat. So this whole action will become Snow White eats the apple. This is one action. So for memory system itself, this is more like a wrapped box, and it will accepting the perception or any requests as a whole and output the corresponding results as a whole. So it starts with the perception of the apple and being hungry, and this memory will first be remembered by the short-term memory. Short-term memory is essentially a linked list that it will contain limited spaces of memories, and by itself, every memory or actions could be repeated and then be enhanced, or could be mutated and forgotten. And any piece of memory that satisfies certain requirements, and generally speaking, the requirements could be the emotion is very salient, or this piece of memory trace has been repeated for so many times, it will be consolidated and actually remembering into the long-term memory. And for long-term memory, it also consists of two parts. First one is semantic graph, for semantic knowledge, of course. And this is essentially a directed graph with memory as nodes and actions as edges. The graph itself could be combined between similar nodes or similar edges, or could be mutated and forgotten. And another part is episodic memory. Episodic memory is just refers to the episodic memory that we discussed in human memory, that they themselves are memory traces and they are individually being mutated or being reappraised, which means and this reappraised result could be used to update the NPC's general knowledge for the world. For example, like 7 years after this traumatic event, Snow White will think about this past, which should be very sad, but she actually felt very happy because she's a very forgiving person. And because of this sad event, she could then meet with her Mr. White. And this should be a happy result. And then she just changed her basic understanding because of this reappraisal. And so combining these two parts, the memory system will then output any as a whole all possible future as memory traces to appraisal, or also respond to other requests like query or so. And then let's talk about the semantic graphs working mechanism. This is a graph showing its basic structure where the memories are nodes. and the action is pointing from one memory node to the other memory node. And memory nodes could be saturated or being totally blank, and the action that is connecting to memory node could be of different happening times and probabilities. Let's use the example also that Snow White has this kind of trace inside of the semantic graph where she was being hungry with the red apple. And after eating, she became satisfied and the apple becomes eaten. And in another time, she also got this new trace inserted into the graph. But this time, she was starting with a green apple. And because these two nodes are so similar, they're going to be combined together. And after combination, the color of the apple wouldn't matter anymore. It's more matter that it is an apple. And these actions could be also combined because they're basically the same actions. And after combination, the probability or the happening times pointing from this hungry state to the satisfaction state would be increased. So this is a combination. And also for other schemes, we can see that Snow White, after some time passed, would have a different slightly changes into the actual memories. Like Snow White could have a slightly positive or slightly more negative feelings toward this satisfaction state. Or so this happening times that pointing from hungry state to the satisfaction state could be mutated, being increasing or decreasing a little bit. And then this traumatic testing event happened that after eating this poisonous apple, given by which Snow White got fainted and almost got killed. And for this time, because this event was so traumatic that it just got saturated, and after this traumatic event for several years maybe, Snow White stopped eating apple and this trace just got kind of forgotten and being blank. So from now on, whenever Snow White is asked what would be the result of eating an apple when being hungry with an apple, she can only think of the result of being fainted. And those happy times that she once had with the apple were kind of gone forever. And then let's talk about the short-term memory. So to simulate the human's memory model of short-term memory with limited space, the short-term memory itself is a looped memory trace. So after one memory trace, the NPC would have done certain action and it would lead to another memory state. And all the nodes numbers are actually limited. So starting from the first empty slot inside of short-term memory, Snow White would remember down this state, being hungry with a red apple. And after the complex appraisal process we have discussed, Snow White chose to eat the apple. And then she will remember down what is happening now is that she's being satisfied and the apple is being eaten. But short-term memory is updating so fast, just like the human memory. If you are losing attention, and it will just fade very quickly. The first memory of being hungry is actually kind of faded, but the second memory of being satisfaction was so thin that she kind of decided to remember this down into her long-term memory. So she will remember down, oh, maybe I was eating a green apple, and then this trace will become her long-term memory and being remembered down to the semantic graphs and also to the episodic memory. We just talked about the semantic graphs, and what is different from between both of them is that for semantic graphs, the attributes will be constantly changing. Like the color of the apple attributes could be changed into red for semantic graph because of they have been combined or they have been mutated or so. Or the whole trace could be kind of blank because this trace didn't happen. Snow White hadn't been eating apple for years. Or this could be totally forgotten and deleted from the system because this node just got so not important and just being blank for a long time. But for episodic memory, this trace, it is updating and mutating by itself. So if there's no forgetting happening to this trace, then she will always remember this trace inside her memory. And the general structure for the episodic memory, the only difference actually is that episodic memory is a finiteness of the memory trace, and with the action that is pointing from memory states to memory states. And yeah, that's basically the architectural part of it. And right now, this simplified graph, well, has already been expanded into this huge graph where starting from the perception of being hungry with an apple, it will fed into the memory system to retrieve any similar events, any similar traces that could be happening after this perception. And this will be helping with the appraisal process to generate the actual emotion and to have the NPC to select an action from it. And then from that, the Snow White could make the actual response of kind of happily choose to eat the apple. And that's about the artifact itself. This artifact is actually based on a psychological paper where a psychiatrist is trying to cure a boy, let's name it Bob, inside of the artifact, and with the insect phobia. And in the artifact, this insect is defined as cricket. And through many sessions of the graduated exposure, which is to let Bob gradually getting used to the existence of the cricket. And Bob will then realize that his previous imagined fear of that cricket would always hurt him or whatever are all false, and then changed his actual attitude towards cricket. And this is the demo of the artifact, just a video snippet from it. So as a player, you could just choose from different exposure events and also choose from different kinds of resulting events and to effect with the emotions generated during session or attitudes and praise generated between sessions. And also to play with the debug modes, also to check with the long-term memory semantic graph to see the real-time Bob's semantic graph, what it has been evolved into. And for one session, actually, you could select 5 combinations of exposure events and the resulting reward events. And between every session, it is the time that Bob will try to really sit down and consolidate his short-term memory into long-term memory and really change his attitude towards cricket based on these last session's experiences. And there are 3 kinds of resulting events, and I'm going to introduce them one by one later. The first kind is that nothing would happen after this exposure. And actually, all the data later I'm presenting are from the lab demos. And this axis is representing the liking toward cricket. And the value is ranged from 0 to 1, where 0 means extreme hatred and 1 means extreme likeness. And you can see after 23 sessions, Bob just evolved from this very hatred toward this kind of neutral phase. And for nothing happening, it will start with the slightest exposure event, which is to hold a jab cricket, and gradually evolved along the therapy time, which is to touch the cricket with foot, and more severe exposure to close eyes and standing in the same row with cricket, and much more severe event, which is to pick up the cricket with a sheet of paper. And lastly, the most severe event here, to pick up cricket with a gloved hand. And you can see the general trend of the recovery speed is starting slow and then beginning fast, because all the liking values are actually polarized inside of APF library to simulate humans' extreme hatred and liking. And there's also another noticeable improvements at start of each exposure period. Like you will see this starting period is very noticeable because actually Bob is having this imagined fear that he would always be hurt by cricket after any kind of interaction he's done with them. So the first encounter would just bring out the most relief feeling, which is a positive feeling from him, and generally make him realize that nothing bad would happen to his interaction with crickets, and he would alter his liking toward the cricket. And the second case is to really send rewards to Bob after each of the exposure. And the rewards are also started from the most rewarding gift, which is the Lego. And actually the rewards themselves are also degrading in their intensity. As you can see, this green line is actually indicating which stage of the rewarding it is given. So like in session 5, the reward has already become the video, but the exposure event is still the holding a jar of cricket. And then at last, this reward will degrade to gifts. You can still notice that the rewards will make Bob much happier and leaving him a generally good impression for this experience, including his interaction with the cricket. So this general good impression will feed to his disliking toward the cricket and making Bob really recover much faster. And it took him like 12 sessions less, nearly half of the previous time, to overcome the phobia. And lastly, you could also actually let the cricket to hurt Bob in the resulting reward selection. This would really enhance Bob's imagined belief that cricket would always hurt him badly, regardless of his interaction. So the prospect itself is very negative, and the actual feeling from APF is also negative. So his attitudes toward the cricket will be worsened and approaching the extreme hatred of 0 after 10 sessions. So these are the 3 typical paths when playing with the artifact, and Bob responded quite differently when encountering the same exposures with different resulting rewards event. And let me introduce you some of the takeaways. This line chart is the current result for Bob with and without imagined fear cases. The exposure selections are the same compared to the previous charts. And this predefined imagined fear is actually not existing in the artifact until we found out without the imagined predefined fear, Bob's recovery isn't that ideal. You could notice that there are ups and downs throughout the curing process, and it actually took Bob, and Bob recovers much slower compared to with imagined fear. And to reach this effect, I actually have done some calculation tricks to maximize the effects of feelings like relief. So this also shows the difference of not liking, which is the darker blue one, and another is the imagining bad things would happen while not liking, which is the light blue one. So Bob, in this case, with imagined fear, is implanted with the fear of getting hurt in the light blue cases, and is really behaving quite differently compared to the other. And also there is this transferring of liking that is happening with reward cases. So for the first 5 sessions for with reward cases, the reward was negative and the liking was significantly noticeably dropping, while the liking for the cricket is going up. So this is a transferring of the liking, and it keeps the same for the next reward, which is a video shown in the orange line, and the next reward, which is the gift, showing in the blue line. So as a result, Bob's liking toward the rewards transfers to the liking toward the crickets, and because he was having a mixed experience of rewards and crickets for every time he was interacting with the crickets. And these are an incomplete list for the current usages for the memory system. Some of them that I didn't cover in the previous talking. And for the future usages, hopefully these AIs in Hitman 2 could react with actual emotions like fear and choose their actions according to their experiences. So some braver one like this would come up and check with what is happening here. And some more shy AIs would just flee away and saturate their fear and make this thing to become their phobia, and that they wouldn't even want to go to this valley anymore. And AIs could be implanted with new beliefs and new ideas along the game playing process because the system Just like the hero in this movie Inception, who did this implanting toward his wife that this world is not real. Also, AIs could narrate their moving past experiences with reappraised emotions and really arouse the similar emotions in other AI's minds. Just like this madam is sharing her experience of healing her trauma, and this sharing actually resonates with the feelings of the audiences. So this extended memory system combined with APF is really a starting point for NPCs to reflect and understand their experiences and the game world. And they could reason with current scenarios, reevaluate memories to evolve their feelings and characteristics, and eventually have a deeper connection with the player. So, and that's all for my presentation. Thank you.
Awesome. Thank you.
All right. Yeah, I have a question. So a lot of all of the actions in your presentation were fairly simple actions, like Snow White eats apple, Bob pets cricket, like person action and a thing he's acting with. How would you handle a more like a non-first person experience, like in the Hitman demo? If you see someone else get electrocuted, how does that can that be handled by your system? And if not, what would you have to change to do it?
Yeah. So actually, this is already handled, and I didn't cover it in the presentation. For the action part, it actually includes not only the initiator, but also the owner of this piece of memory. So like, the soldier sees one AI died on that pile of body, then the owner of this piece of action memory would be the soldier itself. And then followed by the initiator, the patient, and the action itself. Also, there's this float value of confidence to describing how much confidence you have for this information. Like if you are just heard from other kind of sources, like, oh, there's an AI died on the body, and then this confidence might be very low, like 0.3. And you can also set your confidence to 1 if you are just visually directly seeing what is happening now.
More.
Not right now.
You made a comment about that semantic memory nodes can be faded and removed, but episodic nodes are not ever removed.
I was just inferring that episodic memory is updating on its own, and on that semantic graph, like this piece of memory, you could write a separate mechanism compared to the semantic graph. Like you can have every piece of episodic memory that is not memory salient enough to always fade after 1 year of remembering or so. Yeah, it's just updating differently compared to the semantic graph.
But I understand that semantics can change over time. You can train out a reaction like the cricket revulsion, right?
Yes.
And so you can steer it away from an initial semantic node,
Yes.
or have a stronger one replace a weaker one.
Yes.
But I'm trying to reconcile that in my own experience. I feel like something will happen. Like I eat a bad banana and I throw up and it's a terrible experience. And then I just hate bananas. And then 25 years later, I don't even remember where I was when I had the banana, but I still hate bananas. So in some ways, the episodic node has faded, even though the semantic is just as strong. Can you, I'm trying to understand that as opposed to saying the semantics are fluid, but the episodics are concrete. But you have, I guess, a mutation for your episodics.
Yeah, actually, all the things like mutating, reappraising, the forgetting are all also can be seen in the episodic. While for semantic, I was just trying to infer this is the place where the general concepts should be calculated. So this is the part that could be really changed quite differently from its original behavior. But for episodic, they are not supposed to be really changed that far. Like you will not really change the the memory of seeing a dinosaur into seeing an apple. So I was referring to the extent of the changing. These two memories are quite different.
In the mutation itself, whenever you have, like, for instance, like a squirrel example, eating the banana made him really sick, but he had eaten bananas like 1,000 times before that, right? So whenever those are getting combined, what causes the mutations to happen, and what fades, what stays? Like, talk about that.
Okay. So for the mutation, there are mainly three parts itself should be considered. The mutation should be considered whether this piece of memory is salient, emotion salient enough, like if this is a very traumatic or very happy moment. And the other consideration is for the liveness of this node, like if it has been existing for more than 10 years or it's just been existing for 1 month. And the third part is more for edges, but I guess they are the same, like how many times this trace has been exaggerated inside of the game world. So combining all three parts, and you could really tweak the effects you want. Like you can have the emotion salient traces to fade very smallly, very less, and to have it to mutate it very less. And instead, we can have those more neutral memories to really change their formings and to change their probabilities linking from each other to each other. So it's more customized library, I should say.
So let me rephrase. So let's say I ate a banana at my house, I ate a banana at my office, I ate a banana at school. So I've eaten a banana 1,000 times, but they've always been at different places. I've eaten them because I was hungry every time, but there's different places. So since I've had that same action of eating bananas happening 1,000 times, but there are some variables that are the same, such as I was hungry, and there's other variables that were different, like where I was. What would actually get stored in the semantic graph or in the episodic memory with those happening? Because they're not exactly the same, right? But so there's going to be some combination of those. Those are going to collapse together to a single node, right?
Yes.
So describe that collapsing mechanism.
So just as I described, memory, it includes two parts: state of yourself, state of the game. State of the game can also be further divided into state of other ANPCs and state of the objects or etc. And just like for this case of the apple's color, if you are deciding that these two memories are very similar, and for comparison, right now, this system is actually using the text for comparison, for similarity comparison, or else it is 100 similar. And if it is judged that these two memory nodes are quite similar, should be combined, and then the memory themselves should not be so different. I mean, at least under the threshold that you think they are similar first, and then their attributes, their descriptions should be updated. And in my artifact, the description is the state string value itself, and also a float to describing how much of the state you are occupying. It's and for this, it will try to have a best value to be conclusion for these two memories. So that maybe just have the average or now, and you could also have those fancy values if fancy combinations if considering all those memory saliency for these two nodes. And after the attributes is combined, the emotions will be more combined in a moving window average way. Like there will always be, right now in the artifact, 14 copies of emotions remembered for one memory state. So once you change your emotion a little bit, it will just packed and just move the oldest emotion out and have the newest version in, so that you will have a very smooth transition for the emotional state toward this whole memory state.
So right now with your system and the way it's set up, you have this moving average of 14, right? That's keeping track of things
Yes.
as they go. But how expandable is this? Can you change how you're determining likeness? Can you change how you're doing the mutation? What is your kind of setup to allow for expandability if somebody wants to, say, change how those things are happening?
Yeah, actually, most of the functions themselves are expected to be inherited. They are virtual functions, and it is quite natural to have a derived class version and with your customized version of calculating functions for those functions. And then also many of the functional functions, that means they are used in more than one places inside the memory system, like the similarity comparison between two memory nodes. These functions are more designed into a function pointer way, that it has a default implementation, of course, and you can just have the pointer to be pointing to your customized version space.
When you're considering the merge of nodes in the semantic graph, do you need to consider just the nodes or the node action result molecule? That's, for example, I eat mushrooms and I'm happy versus I eat poison mushrooms and I die. The outcomes are very different, even though the starting nodes are similar. Does that affect the chances of me merging the starting nodes? Like, do I just look at node versus node for similarity, or a node action node interaction?
Yeah. For right now in the artifact, the comparison was merely based on the node itself. It wasn't considering the cause and the effects of this memory node with different kinds of actions. And it could be easily added if you want really further steps into the from this node on, because there are also helper functions written like DFS also.
But those functions, does the signature let me look at, if I want to write a custom function to decide to merge, am I just given only the nodes to compare yes or no, or I would have to follow them myself to see where they lead?
Okay, so the signature themselves are actually pointers inside the semantic graph node. So you can use the pointers themselves to follow that yourself, and it's not,
It'll return an entire trace, right?
The trace is as the input parameter, and the function is supposed to write contents into this different kinds of possibilities of traces.
So it will actually return to you a list of traces, and
Yes.
you can make those traces as long as you want. It'll give you that many, however you define that function.
You can query the graph and specify how much, like the quantity of results you want back.
Right now what I have been limiting is the steps forward. I didn't limiting the actual number of results to come back. But of course, in a real application, you really needed to consider those limitations.
Have you done anything special for searching this graph in terms of getting results, or do you just if you want to find all the memories about Apple, do you have to traverse all of memory?
For memory searching, for graph searching, right now, basically it is using the basic DFS for comparison. But I have this query system actually, so that it will support your customized version of comparison and query. Like you want to look for a trace that starts with being hungry, and then followed by the action of eat, and followed by the state of being full. And you can just specify different threshold and different comparison functions for each of them, and then it will return all satisfying traces, satisfying this very vague searching for you.
You were saying this is a breadth first search? Is that what you said?
Yes.
Yeah. So what's like the root of this graph, of either like the semantic or the episodic graphs? Like what is considered the root?
The root.
Or is there like multiple, and what are they?
Actually, for storing, if we are really discuss the implementation for this, because I really need to mention that this implementation may encounter changes, and this is the first draft of the memory system. And then for the root itself, for the semantic graph at least, it is storing in a vector of semantic nodes. And for BFS searching or for general searching, I could just go through all this vector. And if it is for BFS searching, then I'm going to note down every node if I have visited or not, and just to search from that, and then to search for if there. So this is very simple searching for now.
All right, I think we're at the end of our questions. Sorry, there's no time for anybody else. So at this point, if you could step out and everybody else excuse the squirrel, you can stick around if you'd like.
Have this.
You can leave it there. It's fine.
Okay.